Hello students, good morning. Welcome in online lecture. I hope you all are safe and healthy at your home. In this COVID-19 pandemic situation, we change our learning system, so we start our online lectures. In semester 3, I hope you all have our syllabus. If anybody have no, they download it from our university website. According to our syllabus, in this semester we will study our three theory papers and one practical. So we start our theory papers. I start it from paper number IC-10. You also know about structure of this paper. In this paper we have 4 units. So I start it from unit number 3. Unit 3, it is non-conventional sources. Energy from non-conventional sources. In this unit we studying solar energy, biomass energy, biogas from biomass, and ocean thermal energy. And in next unit we also studying three other sources. Why we studying non-conventional sources? At a time we all are know about energy shortage. At a present day, our all energy consumption is from conventional sources, and most ofly our conventional sources like petroleum, coal, natural gas, nuclear energy, etc. But all these are the limited, and formation of all are non-conventional sources. Formation of all are long time. So we did not get it in short time. Therefore, we have changed uses of our sources from conventional to non-conventional. And these non-conventional sources have many advantages. So we studied in semester non-conventional sources. First of all, we start with solar energy. In this topic, we introduce first of all solar energy, its important application and some equipments. Introduction of solar energy. Sun is the largest member of solar system with other members revolving around it. It is sphere of intensely hot gaseous matter with a diameter of 1.39 into 10 raised to 9 meters and average distance 1.5 into 10 raised to 11 meters from Earth's surface. Sun is an effectively a black body temperature of 5777 Kelvin. We also known as it is the surface temperature of Sun. It is effectively a continuous fusion reaction. There is a fusion reaction takes place in sun. Reaction taking place in the sun is the conversion of hydrogen to form helium. According to Einstein's equation, E is equal to delta mc square, and this equation shows that hydrogen H2 plus H2 converted into helium, and it exhibit 25 MeV, 25 mega electron volt. So this energy is produced at the interior of solar sphere at temperature of any millions of degrees. Now you all are see the structure of sun or layers of sun. In the center part, reddish color is known as core part, and after that radiative zone, and then convective zone, and then photosphere, and then chromosphere, and then corona. This is the sixth part or layer of sun. We also study two other matters. One is sunspot and one is sunsphere. So, first of all, we start from the center of sun, that is core. The core is the center of the sun, the same name for the center of an apple. This is where all the sun's energy comes from. We see above reaction from hydrogen to helium. It is takes place in this core part. Second is radiative zone. The radiative zone is the zone around the core and it produces gamma rays and X rays that move core's heat energy towards the surface. After this, it is known as convective zone. Convection is when heat rises and colder gas, liquid or plasma sinks. The convective zone is made entirely of boiling plasma, ending heat up the sun's surface. According to some theories, there is a temperature of core part is 1.5 crore Kelvin. So at this temperature, most of matter is in core part as a plasma. After convective zone, next layer is known as photosphere. Photo means light. The photosphere is like a surface of light that covers the sun. The remember this, I think of photos on a sphere. After this, it is known as chromosphere, a layer of sun's outer atmosphere. The chromosphere is reddish glow. Chromo means color and sphere means ball. So it's a ball of color around the surface that can be seen during an eclipse. I like to remember this word by the first sound crow, thinking of how they can fly around above the surface. After chromosphere, it is known as corona. This is not COVID 19, it is sun's layer corona. Corona means crown in Latin. This outermost layer of the sun's atmosphere can also be seen during the eclipse, like a crown surrounding the sun. In full sun eclipse, we show this corona at very good structure. We studying here six all parts of sun. Next, sunspots. The sun same times got spots on this surface that are darker and cooler. And last one is solar flare. The sun is so active that sometimes the energy bursts out with the flare. We also known as sun is a hot gaseous sphere. So we show solar flare at surface of the sun. Now it is all parts, all 8 are described here together. This figure shows the some sun structure and radius of different types of layers. It is estimated that 90% of sun's energy is generated in the region of 0.25 r, that is the radius of sun. It is shown in figure here, radius of sun, where in its average temperature is not described in this figure, but it is shown in next. But we study here its average temperature and density are 40 into 10 raised to 6 Kelvin and 10 raised to 5 kilogram per meter cube respectively at a distance of 0.75 r, that is the year 0.75 r. From center, the temperature dropped to about 1.3 into 10 raised to 5 Kelvin and density 70 kilogram per meter cube. Outer most layer of this zone is called photosphere. We show it above. Above photosphere is layer of color gases or several thousand kilometer deep called reversing layer. Outer layer is chromosphere. Energy in the form of photochemical waves. The amount of energy intercepted by Earth is about 17 into 10 raised to 18 kilowatt, which is only a tiny duration of total energy release by conversion of 4 million tons of hydrogen per second to helium in the sun. Please note this is the main point. In fusion reaction, 4 million tons of hydrogen per second to helium. So we have much more energy from the sun. This figure shows the different distance, layers distance from each other. This figure also shows some temperature, density and distance of each other layers. This figure shows different layers temperature. And this figure shows different layers and their particular matter. The total gradient flux of the sun is about 17 into 10 raised to 18 kilowatt, and the energy is stored on a earth surface of each year by radiation of hot solar rays and the rate of 1.35 kilowatt per meter square, which may be about 55,000 times more than the world's energy requirement during the next century and 50,000 times more than the present days energy available from all sources. Thus, in principle, solar energy can supply all the present and future energy needs of the world on continuous basis. This make it one of the most promising unconventional energy sources. So we studying the solar energy as non-conventional source. Now, the advantages of solar energy. It is a clean fuel and freely available in almost all parts in the world, unlike fossil fuel and nuclear fuel. At present day, we we have only two these sources for our energy. One is fossil fuel, that is petroleum, coal, and natural gas, and second is nuclear fuel. And all these sources are limited, and their stock is also limited, and formation of its are very long time. So we have changed our scenario to non-conventional energy sources. Problems of solar energy. It is dilute source of energy. Hence, large collecting areas are required. Many applications and results in higher cost. And number two, variation and availability occurs daily because of night cycle and also seasonally because of Earth's orbit around the sun. Now, solar energy utilization. We have two methods. One is direct method and second is indirect method. Indirect method we have thermal application and photovoltaic application. And in indirect methods, formation of water power, wind energy, biomass, wave energy, and ocean temperature difference. So, in this unit, we studied detail about these direct and indirect methods. In this lecture, we studying detail about sun and temperature, distance, density, etc. parameters of different layers. I have one videos, so I attach it. You all are see. In this video, we see about the sun's layer. 6 layers of sun: core, radiative zone, convective zone, photosphere, chromosphere, and corona. 3 are internal layer and other 3 are outer layer. Center part of the sun is known as core. Its distance and temperature 1.5 crore Kelvin, and there is a fusion reaction, and all matters are in core is in plasma state. Second is radiative zone, its distance, temperature. Next layer is convective zone, its distance, temperature. Next one is photosphere, its distance, temperature. Photosphere is like this. And chromosphere. At a full sun eclipse, we show this structure. And last one is corona. And this is distance, temperature. We study two other parts of, that is the corona.